Here's a nice and tricky one that I've been sent today, courtesy of Michael in Karlsruhe. Okay, this is the molecule. It looks all fine. Let's hide the text in the background. Just two lines, so we see something happens, but it isn't in the way. This thing we don't want either, so we hide it. And let's have a look at the data. It's a good high-resolution data set in Molly, Iowa Sigma 32. Now, what does that actually mean? Let's have a look at the stats, Iowa Sigma versus resolution. And yes, a really, really strong data set. So the Iowa Sigma 3 line is all the way down here, so all the data are very, very good. And it's highly consistent, 2.65% R-end. So obviously there's going to be some solvents, counter ions, things floating about. We can already tell there's a peak of 20. So let's refine this. Control R, and I'm going to use keyboard shortcuts for this. Q peaks are invisible, so Control Q shows the peaks. Now that's not anywhere near enough peaks, so we're going refine 4 cycles and 20 peaks and see what we get. So instantly we know there's a couple of rings here, so that looks pretty good. That's probably just a standard pyridine, I would say. Nothing is grown, so let's deal with that first. We can go into work and look at the Q peak intensities. 5, 5, 5, they're all roughly the same. 5.5, 5.8, so let's just make this the nitrogen, name N, and then make the rest the carbons. Use the up key and just replace the last letter. Okay, what else have we got in here? There's the big one. So it's probably a perchlorate. So there's something needs to be grown or put together, and there we go. There's a perchlorate here. Now let's have a look at this. Yes, that's what I thought. It's all growing into each other. So what I would like to do right now in the beginning here, before we even start on this, is to actually just import that perchlorate, because that doesn't look like a very nice geometry. It looks like flat here. It's probably disordered. So rather than starting with the disorder, just head over to the fragment DB and get a perchlorate. Perchlorate. And there we go. It's going to be disordered over symmetry element, as we've just seen, because it all grows. So we have part -1, and we set the occupancy to 1/2, and we fit it. So we import this. Probably, I wouldn't even nail it on the chlorine, just nail it on the on the oxygens here. So 1 here, then number 2, and 3 and 4 here, and then let's maybe move this over here. And I think we've done enough work for now. Let's just refine this. I hit escape a few times. So we've put in a pyridine and a perchlorate. That should be at part -1. It is, and occupancy 1/2. So hit Control R, refine it. And that looks like it's behaving quite nicely. There's other stuff in here, so let's just, it's a grown structure, so we need to type fuse first. Put all these peaks together and see whether anything sensible happens here. So there's something here. Let's go Control G on this. Oh yes, it grows. And that peak here looks a bit bigger than the other. 6 and 3. Yeah, okay. So this is symmetry equivalent. So this is probably diethyl ether. So we just go shopping again and type ether. And there it is. So again, it's over the symmetry element with the oxygen in the center here, and we import it in the same way, -1 and 0.5. We fit it and start on the oxygen in this case. So 0 and 1 here, and then we nail this one here, and then the last one, this one here. And that covers those peaks quite nicely. And again, the occupancy should be 1/2 and part -1. And let's refine this. And this is now the grown version of it. So if you go fuse, then we see the single version of it. And I would suggest what we do now, be bold, type anis, refine everything anisotropically, Control R, and see where we get to. That doesn't look unreasonable. I think we can try to H add on this, so not everything added properly. So in fact, it didn't add properly at all. So what I suggest to do here, this is a little trick as well. We can hide the Q peaks, and we know that this has got to be this. So I'm going to type h add 137, so that puts that in regardless whether the geometry really fits or not. 137, and that's a 23, and that's a 23. Let's refine this and see what we get. That doesn't look unreasonable. The R factor of 4.9% at the moment. Things are obviously moving, but that's to be expected. So let's add hydrogens to this pyridine, H-add, and have a look at what we've got left in terms of Q peaks. So there's something else in here, and that looks like it's going to be trouble. Control G, Control grow, nothing really grows here. We've got a lot of peaks already showing, and this doesn't grow. So this is an interesting one. So what I suggest to do in this case is just put 2 carbons in here and see what we end up with. Yep, there are more Q peaks around it. They're 1.7, so they're quite sizable. Let's just press on and make more carbons out of them and see whether we can eventually see something or anything that makes some sort of sense. Control G. It's not finished yet. Control G. Oh yes, it grows. Okay, so that really does start looking like a 6-membered ring and some sort of disordered arrangement. Let's refine this again, see whether anything moves but majorly here. So yeah, there's a bit of a mess. So the way you would deal with this in Nordics 2 is pick out a set that sort of type first to go into that mode. So pick out a set that sort of could make some sort of sense. So we just delete that one, and we delete that one. It's not a nice one. It doesn't look like a very nice 6-membered ring at all. But let's just start with this and see where we get to. So we select all of those, Control Q to get rid of the peaks. And the trick here is to type part -1 minus C, and then type fuse again. Now this has made them unique, and there is actually a doublet here. So what happened here is that it hasn't deleted the symmetry equivalent that we needed here. So what we need is a fuse 0.1 or something, and that gets rid of it. And now we just got to make sure that this is still in part -1, and we want to set the occupancy to 0.5, so it's fixed. And now I suggest to put an affix 66 in for the time being, so it becomes a nice regular ring. Control R, and we get a nice regular ring here. And if we look at TELP, we probably see something horrible, and we do indeed. Let's refine this a few more times and see whether anything shifts here. It does actually equalize out quite nicely. Control R again. And the R factor is 3.47%, so that's not so bad. So just nominally, let's put a nitrogen in here, name N, because we know it's got to be pyridine, and double click on that, H-add, and that put a hydrogen on the nitrogen, so that's obviously not right. Let's be careful here. Control R, and well, let's just go harness on it and see what happens. This is a bit silly now, but let's just try. And yeah, this doesn't look very nice, doesn't look very good, but that's kind of expected because this is obviously symmetry. You know, you can challenge this all on top of each other. What we could try to do is Control H first to get rid of the hydrogens, double click on this, and then do a really strong rego 0.001, just something silly, and see whether there is any 3.14. So it looks nice, and the R factor is 3.22. So the R factor hasn't actually gone up significantly, and we've got something that is not ideal. And I'm not advocating that this is the final solution, but it's you know, for something that we did in 5 minutes, it's not a bad starting position to finish that structure off. So we now got no significant peak left, and what's moving? 1.49. Let's have a look. It's obviously those ones here. So let's just give it a good spin. Refine 20 cycles, and just follow it up and see what happens. Yeah, it's actually settling. It's not a very pretty pyridine. In fact, one could argue that maybe this pyridine is not really worth modeling altogether. So just for the sake of the argument, I'll show you what you would do if you didn't want to model it. I double click on all of this and delete it. And what I'm going to do now is click on the refinement and actually use a solvent mask. So we are going to update the mask, and that also switches on the use the solvent mask. So when we refine this now, it will first calculate the area where this pyridine sits, and then it will evaluate the electrons that must be in there. And this will basically get rid of this, and we now have an R factor of 3.02. We've got 40 electrons. How many's got pyridine? I could do adding up, or I could double click on this and type info, and the electron count is 42. So that's a very close match to the number of electrons we find in there. So I would probably advocate to use a form of squeeze, or our own version here, squash. Make sure this is all settled, refine this again, and what I've done is still updating the mask this time. So the next round I'm going to no longer update the mask, and now it's going to use the mask that you calculated in the last round. And now I can write in that these 40 electrons are 1 pyridine. And I can do the same in this one here, 1 pyridine, and this will now stick. If I refine this again, it goes through to the zip file, where I will show this in a second. We head over to the report area and merge zip, where it puts the zip file together, and right at the bottom here, so it puts all the data in, it puts the FAB file in, and down here there should be, let's search for it, let's go up to the top and search for SMTBX, and that's the mass special details, and it puts in the number of electrons but also the contents of the void, so your referee doesn't have to guess what you might have squeezed out. I think the structure isn't too bad. It shows you what's present, the perchlorate and the diethyl ether and the pyridine, and there's another pyridine hiding in the that we squeezed out, or we masked out. But in terms of chemical information, everything is here. In terms of crystallography, everything matches up. So now it would be your job to fix the formula and make sure the moiety formula is correct, but that's maybe for a different video. Thanks for using OLEX2.